Hello and welcome to this introductory video about ellipses. An ellipse is an oval curve that looks like an elongated circle. More precisely, we have the following definition. So here is the geometric definition of an ellipse. An ellipse is the set of all points in the plane, the sum of whose distance from two fixed points f1 and f2 is constant. And these two fixed points are the foci, which is the plural of focus. One is focus and two foci. Okay, and so the geometric definition suggests a simple method for drawing an ellipse. So you can place a sheet of paper on a drawing board and insert a thumbtacks at the 2 points that are to be the foci of the ellipse. So let's see this animation. So here is the thumbtacks, and you have a string and a pencil on a paper board. So then you carefully move the pencil around the foci, keeping the string taut at all time. The pencil, as you see here, will trace out an ellipse, and that's because the sum of the distance from the point of the pencil to the foci will always equal the length of the string, which is constant, as the definition of the ellipse state. And another observation here is this: as we make this distance between the two foci smaller and smaller, we see how the shape of the ellipse changes. And so if this distance is 0, and that means f1 and f2 are at the same point, the shape we will draw using the string and the pencil will be a circle. So the ellipse is closer to a circle in shape as the distance between f1 and f2, or between the foci, gets smaller and smaller. And so let's see here and learn some terminology. So as we've seen and we talked about, this is the focus, f1, f2, and the distance from the center to the focus, we call it C. So this distance is C. And the distance from the center to this point here, the longest side, we call it the vertices. This point in red are vertices. So we have V1 and V2. So these are vertex 1 and this another vertex 2. The long side, this axis here, we call it the major axis. That's because the longest side. This part here, we call it minor axis because it's the smallest. Sometimes you see the y-axis is the major axis, so it will be elongated toward the y-axis. Here this ellipse is elongated toward the x-axis. So the distance from the center to any of the vertices is A, and the distance from the center to the along the minor axis, we call it B. So it is important to remember these distances. From the center to the focus is C, from the center to the vertex is A, and from the center to the other side of the minor axis will be B. So even if it's elongated toward this along the y-axis, this distance, the largest one, will be A, this one will be B, and the focus is always on the major axis. So this distance here will be C. It is very important to remember this fact. So let's see how we get to the equation of an ellipse. To obtain the simple equation of an ellipse, we place the foci on the x-axis So we have f1, which is minus c0, f2, which is c0, and as I just said, the distance from 0 to from the origin to foci is c. So that's why we have positive c and negative c, and that's what we have here. And so that the origin is halfway between them, as you see here. For later convenience, we let the sum of the distance from a point of the ellipse to the foci to be 2a. Why is that? So as you remember, when we draw, you saw the animation of drawing this ellipse when the pencil was here, which is, this is the same string, we don't change it, it's already fixed length. So as the string is here, so you have c here and another c here, but this distance, remember, the string goes up and go back here. This is this little small distance here is twice, is counted twice. So if you take one part of it here, then you'll have basically a and another a, which is 2a, and this is why this string here is equal to 2a. Then if P is xy, you choose any point on this ellipse to be xy, we have this distance from P to F1 plus from P to F2 is equal to 2a, as just we saw, because the string is equal to 2a. Then we use the distance formula. We get square root of x plus c quantity square plus y square plus the square root of x minus c quantity square plus y square equal to a. It's or you could write move the this one here and the other one, so you get this equation here. Then you need to do little algebra by squaring both sides and work it out the equations, and for convenience we let b square equal a square minus c square. So this is for convenience, and using that algebra and substituting b square with a square minus c square, we end up with the equation of the ellipse, which is x square over a square plus y square over b square equal to 1. So let's see here the equation of the ellipse when we have the measure axis is the x-axis or the measure axis is the y-axis. So the standard form of the equation of an ellipse with the center at the origin. So as we see here, this is now the measure axis, the x-axis. So we have c in here, and we have a is to the vertex. Again, this is called vertex. The same here, the other vertex. And so the equation would be for an ellipse always x squared, and it's a plus y squared, it must be equal to 1. If it's not, you make it equal to 1 by dividing with that constant, as we can see an example later. And so what goes on the x-axis is a, which is the largest in this case. So a is on the x, b is on the y. So what goes under the x will be a square, under the y, b square. And here, remember that c square is equal to a square minus b square. And that's because we choose earlier, we said let's make b square is equal a square minus c square for convenience, and therefore c square is equal a square minus b square. From that substitution we made to make the equation simpler. So for the measure axis, that is the y-axis, again this is a, which is on the y as you see, and the b now, the b is always the minor, the smaller, it's on the x. So I always write x squared plus y squared equal to 1, and what goes under the x-axis, under x, is what's on the x-axis. I have a b in here, which is b squared, and what goes under the y, we have the measure is on the y, so I have is a, so it will be a squared. So as you see here, if the measure axis is the x-axis, the what's under the x is the largest. And if the measure axis is the y-axis, what the number under the y will be the largest. And I hope this video is